Okay. Okay, first thing, I want to discuss yesterday's assignment, and then I want to make problems like 51 through 55 infinitely easy. I mean, incredibly easy. Okay? So what do you have questions on? 27. Okay, let's take a look. Oh, yeah. Okay. Does anybody know if Tay is sick or if she was planning to be gone today, or do you have any idea? Okay, I appreciate that. Okay. 27. We got some work to do on 27, but it's really not as bad as you might think. Okay. Limit as x approaches 0, x cosecant of 2x all over cosine of 5x. First of all, let's just go ahead and do our trig simplifications. Let's try and get at least two, because really the only thing we know much about is sine x over x, and we do know something about cosine. Cosine is not really a problem at 0. So let's just go ahead and simplify. X times cosecant is 1 over sine. So 1 over sine of 2x over cosine of 5x. Okay, so now let's reorganize this in a way such that we see a sine, an x and a sine x compared to one another. I'm going to pop way down here. Limit as x approaches 0. Let's go x over, can somebody shut the door, please? Times 1 over cosine of 5x. Okay, I want to make sure I haven't lost anything in conversion here. Okay, so I think we're okay. Now let's think about each particular part. This would be nice if this was 2. So you know what? Make it 2. If I make this 2, what do I have to put outside to counteract that 2? 1/2. Okay? Because I got the 1/2 times 2. That's now going to cancel out. So it's like I didn't do anything. I'm just changing its form. Okay? So now we can actually go ahead and take care of this. We did enough of these yesterday where the reciprocal of this is still going to be 1. Okay? So we have 1/2 times 1 times, now cosine, it seems like this might need to be a little bit more complex, but as I'm looking at cosine as x approaches 0, it's just 1 on the bottom. So that's where they get the 1/2 from. Okay? So remember, our goals is to get this particular setup. And then anything else, at 0, cosine's not a problem. Not a big problem. First of all, let me ask this question. Is that the right answer?
Yes.
Thank goodness. Okay.
You also do 25.
I hope so. Okay, tangent limit as x approaches 0. Tangent 2x over x. Well, let's go ahead and get it down to sine and cosine. So I get limit as x approaches 0, sine of 2x over cosine of 2x over x. Sometimes, especially when I'm dealing with trig and you throw in limits and this, that, and the other, this really feels like a foreign language. It really does. It's like, I don't know, what is this? Okay. So now I'm going to go ahead and do some magic on the top. I'm going to go ahead and show what I'm doing more than I did last time. I'm just multiplying by the reciprocal. We all know that. And I'm going to go limit as x approaches 0. Let's reorganize. We're almost there. What do I need where? A 2 on the bottom. So then what do I need to do to counteract that? So it's 2 on the bottom, so I'm going to need a 2 on the top to cancel what I just did. And I could have written it inside. I could have written it outside. It doesn't make any difference with with limits or later on when we get to derivatives. It's the same scenario. So now I've got 2 times this limit right here, 1, times this limit right here, 1 over 1 is 2. Again, anything, I forget who it was, well, not really, but one of you guys on your last quiz said, you wonder how much you understand this stuff. So at any point in time, if you're not quite sure exactly where I'm coming from, ask me, and I'll try and explain it a little bit better. To help you, Willa?
Yep.
Okay. Home volleyball tonight?
Yes.
Against?
We play Humphrey first, then we play Liverpool.
Okay, that's right. Let's take a look at 51 through 55. In my opinion, 51 through 55, first of all, it's important for you to understand kind of where they're coming from as far as dividing everything by the largest power of x. And then seeing as it approaches 0, a lot of those things are going to disappear. But 51, I think 51, you could just look at it and see it's 2/5. How could I see that? The first two. Okay? Here's the way I look at this. There's a battle between the most important term on the top and the most important term on the bottom. And when I say most important, it means the highest degree. Okay? Like if I put in 1,000, it's going to be 2003. On the bottom, it's going to be 5007. That plus 3 and plus 7, did it really make much difference? Not at all. There's this battle going on between the 2x and the 5x. Between those two terms, one is not more powerful than the other term, so it's just going to take you to 2/5. Okay? Because imagine if I, like I said, 2003 over 5007, well, it's going to give me something a little bit different than 2/5, but it's going to be pretty darn close. Now imagine if I went to 1,000,000, 2,000,003 over 2,000,007, the deviation that plus 3 and plus 7 cause is going to shrink and shrink and shrink and shrink and shrink as x gets larger and larger and larger. Okay? But then we run into 53. 53, the answer to that one was 0, correct? Okay? Well, let's use the same logic here. Well, wait a minute. I don't have equal powers on top and bottom. Okay? So how can we explain this goes to 0 without doing all this stuff of dividing by x squared? Well, is the top getting bigger as I go to infinity? Yeah, top's getting bigger. But is the bottom getting bigger, bigger, bigger? Yeah. Yes, why? Because it's squared. Okay? So in this battle of top versus bottom, the bottom's going to win. Now, this is when we're thinking about plugging in arbitrarily large numbers. Like 1,000,000. Get ready for this. 1,000,000,000. Wow. Good job. Or even 1,000,000,000,000.
What?
Yes, exactly. Okay. So, yeah. The bottom's going to get bigger and bigger and bigger and bigger and bigger faster than the top, so it's going to get closer to 0. Okay. And on 55... it's going to be the scenario where I have the top and bottom have equal powers, and we're getting closer and closer and closer to 7 over 1. Yes?
In those examples, it asked us to do it for negative infinity. How is that different?
That's a great question. I've never even thought of it mattering at all.
Because it was the same, like the answer.
Yeah, it doesn't matter.
Okay.
It doesn't matter. And the reason it doesn't matter is like say something on, if we do the first one, it's going to be positive 2,000, blah, 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 positive or negative, that it's still going to 2/5. Okay? But when I come down to something like 55, it's cubed and cubed, so whether they're positive or negative are still going to be the same. On the right side, it's going to be positive. The left side is going to be negative. But if it was squared, it'd be the same thing. On the right side, going to positive infinity, it'd be always positive. Left side, going to negative infinity, it's always going to be positive because it's x squared. So it's really a moot point. Great question. Great question. So here's what I'm going to have you do. Grab whiteboards, please. Let's see if we can do these other ones in our heads. Well, not having walked in heels for a long time, is it difficult?
I mean, it gets tiring.
It gets tiring. Because I used to every once in a while. I've kind of left that part of my life behind. But no, I'm joking. But it always looks like it's like, okay. You remember how I said I went to the Prince Mansion? Did I tell you that? Oh, my sister and we went to the Prince Mansion this summer. And we got to tour his whole mansion and everything. Hence, that's why it was a tour of the mansion. 2 hours long. We got to see everything. This guy was tiny. He was 5'2", and he was really sensitive about his height. So he always wore the tallest heels ever. And he's 5'2", and his shoe size was a woman's 5.5.
That's more than my feet.
Yeah, teeny tiny itty bitty feet. Okay, so here we go. So, with what we just talked about, I would like you to write down and show me what the limit is for 52.
Wait, give me a second. Oh.
I am giving you. There you go. It's 2. Okay? It's 2. Why is it 2? Because the top and bottom, they have the same powers. And so there's no great big advantage the top has over the bottom or vice versa. Okay? And it's just the top's getting closer to, if we would do the dividing by x to the third, having seen that, you can probably visualize that as well, whichever way you want to do it. It's going to be 2 over 1. 54, go. Okay, we have this battle going on. Who's winning the battle, the top or the bottom? The bottom's getting bigger. The bottom's getting bigger. The bottom's getting a lot bigger. The bottom's getting bigger. So the bottom's getting bigger. Think about what happens when the bottom of a fraction gets big. When the bottom of a fraction gets big, it gets close to 0. Okay, 56, go. All right, 0. Good job. Okay. Good. No, not at all. Not at all. I'm not here to trick you. Unless I tell you that I made those worksheets, but that's a whole other story. Okay. 57. Okay. It is 0. Good deal. Why? Because the bottom. Now, the top is going to be a huge gargantuan number. That's true. But if I plug in 1,000, well, the top bottom is going to be approximately 1,000 times bigger. Okay? 58. All right. Good. So in this one, the powers are the same. So the x to the fourth over x to the fourth, that's what we're looking for. And it's just going to take us to 9 halves. 59. Good. Good. Okay, 60. Wrap it up. Little peer pressure there. Yeah.
I was glitching out.
You're glitching out. Yeah, -1 is the answer. Okay? So now I want you to draw me a picture of what you're going to do tomorrow.
Ooh.
You got a day off tomorrow, so draw me a picture of what you're going to do. Oh, cool. Is that in Omaha?
Yep.
Okay. All right. Do a little golfing tomorrow?
Yeah, Top Golf.
Top golf. Okay, cool. Okay. Once you're done, you can erase it and put it away. Yeah, Melissa's gonna spend some time in bed. All right. Practice. Got P2T, dentist, and what's that thing on the lower left?
Oh, that's my teacher.
That's your teacher.
My teacher.
Okay, so is that Mr. Medell?
Yeah.
Oh, okay. Hence the larger teacher.
Oh.
I know Mr. Medell. I've taught with him for years.
Yeah.
He was a teacher at a.
He's been nice.
Yeah, he's a good guy. Okay, so what is
So
that?
I'm at PTT and I'm working.
Oh, okay. At Subway, is that right?
No.
Yeah.
No.
That's
Where? Runza.
Runza.
That's right.
Oh.
Northeast Eye Care.
Work.
Okay. Are you the receptionist or what?
One of them was at their wedding, so I become
Okay, good.
I play everything.
I'm going to stand
Okay.
Without the pay.
What? Okay, Kat. I haven't seen yours.
Oh.
Joe.
I'm not an artist.
Yeah, you don't have to tell me that. I got that figured out.
It's a door. I'm going to our apartment.
Leah said they were cute.
What?
Leah said
that's
they were
heels.
cute.
Heels.
Who's Joe?
My sister.
Oh, okay. Okay. Whiteboard's away.
Guys, I got put on my spot, okay? I'm just kidding. I don't think I was thinking about how we well, anyway, I think we'll find what these are.
So here's what we're going to do. I kind of got to look at the next section. I was like, now, wait a minute. We've done a lot of stuff. We've done a lot of stuff with these limits already. Okay? So we're going to stop. We're going to do a review. We're going to have a test sometime this week. If it would be perfect to do it Thursday if we had class tomorrow. So here's what we're going to do. I took her old test, and I'm going to use that as a review for you guys. Okay? This is not a test. Okay? This is a review for you. Okay. Trying to get that so white balances properly. This is such a trouble. Okay? So here's my plan. I'm going to give this to you guys. Okay? And throughout the class period, you can ask questions as you come across them. Okay? I actually, you know what? I should probably give you a copy of the key too, shouldn't I? So you know whether you're right or wrong. Okay? And then Thursday we'll come back. We'll open the class with any questions you might have. We'll start the test on Thursday. We'll finish it on Friday. Sound good?
Yep.
Okay? Okay. So today is your time. Okay? Forcing you to go back and take a look at it. If you want to work with somebody else, you can. I will flip through this for Tay here. She can take a screenshot here and there. I've got to get this figured out.
Oh my gosh, rate of change felt like forever ago.
You what?
The rate of change felt like forever.
Yeah, I was like, okay, we better just stop, take a break here. You know, I'm going to go ahead and do this half page by half page. Taking
Oh,
screenshots.
I forgot to put it up.
And feel free to work. You guys can work together a little bit if you want, or help each other out when you get stuck.
I got a 10.
How did you do it?
You have to find the lines by plugging in the x's through the.
Are those both X's?
Yes, that's the interval that you're interested in finding the rate of change with. So you got to find your 2 points,
Okay.
and then find your slope. I will go get you guys copies of the key.
So the 2 and 4 goes with X's. So you turn away 2.